Hello everyone, this is Dr. Chantel Marshall once again. In this lecture, we're going to practice using the two-factor ANOVA to understand what's going on with some of our data. So we'll do some hypothesis testing using the two-factor ANOVA. So let's go ahead and start with some practice problems. This problem is going to focus on video games. So let's say that researchers were interested in whether different types of video game players can accurately rate the difficulty level of a video game. They brought in novice, or people who don't ever play video games, and regular video game players to play one of two different video games and rate the difficulty on a scale of 1 to 30. So here we have two groups of people. We have regular video game players, so these are people who play on a regular basis, and then we have novice players. So these are people who rarely, if ever, play video games, and then they're going to be playing two different video games, so one or the other. So for this problem, I want you to show all four conditions of the study, figure out what the factors and the levels of this study are, and then state the three null hypotheses. So if you haven't already given this a try, I want you to go ahead and pause the video here and do your best to figure out what the answers to these three questions are. Once you're done, go ahead and look to see how I've solved these problems. So if we want to look at the four different conditions that have been put together in this study, let's take a look at the two factors. So here we have the type of player that has gone into the study, and here we have which video game it is that they're playing. So before I even show you all four conditions, let's go ahead and label our factors. So, factor A is type of player. Okay, so we have, again, the level of a regular player and the level of a novice. So your factor is this overarching description of what's going on within that factor, so type of player. And then the levels are the specific groups that you have created. So in this case, level 1 would be regular players and level 2 would be novice players. The other factor we'll call factor B is the video game that they're playing, right? So we haven't been told anything else about these video games other than there's just two different ones. So in this case, I'm only labeling them game 1 and game 2. So the factor here is video game and the levels are game 1 and game 2. If we'd been told more about the games, we could label them more specifically. For example, maybe one's a shooting game and one's a driving game, but we don't have that information. So we're just going to call them game 1 and game 2. Now, as you learned from the lecture, what we're doing is crossing these factors, and so we end up with four separate, distinct groups. So the first group is the group of regular players who are playing video game 1. Okay? The next group is regular players who are playing video game 2. So I want to make it very clear that these here are not the same players. This is one group of regular players, and this is a second group of regular players, and they're each playing a different video game. Then we move on to the novice players. So we have one group of novice players who are playing video game 1 and a second group of novice players who are playing video game 2. So now we have fully crossed factor 1, which is type of player, with factor 2, which is which video game. All right, so now we've seen both the factors and levels as well as the four conditions that this creates. So now we're going to move on to our null hypotheses. Remember that when we are working with two-factor ANOVAs, we have three different null hypotheses that we may or may not reject. So I'm only having you write the null hypothesis for each, not the alternative. But you can figure out what the alternative is pretty easily. So when you write your null hypotheses for these, you start with your two main effects, and then you go on to your interaction. Remember that each main effect has to do with the effect of each factor. So we'll go ahead and start with factor A, which was the type of player. So our null hypothesis is always that there's no difference. So there's no difference in ratings of difficulty between regular players and novice players. Next, we'll move on to factor B, which in this case was the video game. So we will say there is no difference in ratings of difficulty between video game 1 and video game 2. Okay, so these two are the null hypotheses for our main effects. Again, those are the effects of each individual factor on its own. Now we have to come up with a null hypothesis for the interaction. So in other words, do these two factors interact or form a sort of different effect when they're put together? All right, so in this case, our null hypothesis is there is no interaction such that, so I'm putting it in sort of more informal language, the rating of difficulty of the two video games does not depend on the type of player. Okay, so does not depend because this is our null hypothesis. So any differences in the video games will not depend on which kind of player is playing that game. So when we are running a two-factor ANOVA, the interaction is really what we want to find. So that's the null hypothesis that we would most like to reject. The main effects sometimes can be significant and sometimes can't be. It's not as sad day when we don't reject the null hypothesis for the main effects as it is for not rejecting the null hypothesis for the interaction. Okay, so this, again, we're testing 3 different effects in the two-factor ANOVA, but it's that interaction that's really what we want to find. All right, so let's look at what the data look like for these players. So here's a graph. We've graphed the regular players on the left, and these are the results for video game 1 and video game 2. And then we've graphed the novice players on the right. So here's their score for video game 1 and their score for video game 2. All right, so we can see that there are definitely differences in how they rated the difficulty of these games. So for regular players playing video game 1, they rated it a 20 out of 30 in difficulty. They rated video game 2 a 15. But when we move on to the novice players, we see that they rated the video game 1 as 10 and video game 2 as 5. So I'm going to put these numbers into a table. I personally really like to see the data in a graph form to be able to interpret the main effects and ANOVA or interaction, but I know that some people prefer to see the data in a table. If you only have your data in one way and you prefer the other way, I suggest that you draw it out in the other way so that it can make more sense to you. But we'll go through both sets to look at any main effects and the interaction. So the first main effect we're looking for is type of player, right? So are regular players rating the games more or less difficult than the novice players? So is there a difference between type of player? So if we look at these bars, their average is about here. And if we look down here, their average is about here. So that looks like it's a pretty big difference, right? So we're going to say that there's most likely a main effect of player type such that regular players are rating the games much more difficult than the novice players. And I know that you're used to calculations and you want to know precisely and exactly whether or not we can reject that null. But like I said, I'm less interested in you being able to calculate this as I'm interested in you being able to interpret what a main effect is and what an interaction is. And so for the purposes of this lecture and this lesson, we're not going to be doing the calculating, and instead we're simply going to be looking at graphs and tables. All right, so when we look at our table, we can also see that main effect play out here. So we can see that both of these numbers here are bigger than both of these numbers here. So it looks like regular players, again, are on average finding both of the games more difficult than the novice players are. And this could make sense, right? Regular players kind of get the hang real quick of how difficult a game is going to be, and maybe novice players are just not experienced enough to understand when a game is going to be very hard. All right, the next main effect that we're looking for is between the video games, right? This is factor B. So we want to see if there's a pattern such that video game 1 is different than video game 2. And as we can see from the graph, for the regular players, video game 1 is being rated as more difficult. For novice players, we also see that video game 1 is being seen as more difficult. So it looks from the graph that we do have a main effect of video game, such that video game 1 is being rated as more difficult as video game 2. And we can also see that in the data. So we see that video game 1 for both groups is being rated as more difficult than video game 2 for both groups. All right, so we've looked at our main effects. It looks like we have a main effect of both factors. So we see a main effect of player type and we see a main effect of video game. Now we're going to look for the interaction. And the interaction is a little bit more complicated. And so what I'm going to do is simply use my lines to see if they cross. Because remember, if they cross, that means that we have an interaction. So I'm simply going to put a line between my two ratings for video game 1. So the difference here goes down, right? We move from regular to novice. We go lower. And then we're going to do the same thing for video game 2. Right? From regular to novice, it also goes lower. So you can see that these lines are basically moving in parallel, right? So they are not going to touch. Even if we extend them far, 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 they're not going to touch their parallel, which means that the interaction is not significant. So we cannot reject the null for the interaction. So it looks like any differences that we found between video game 1 and video game 2 do not depend on the type of player that's rating the game. All right, and so in this case we have two main effects and no interaction for these data. All right, so a little sad we didn't get to reject the null for our interaction. Like I said, that's usually the one that we're most interested in when we run these studies, because it's the only way to see if an interaction is actually significant. All right, so let's move on to one other example. Researchers were interested in the length of time for a conversation, and this is going to be measured in minutes, between two people, depending on their relationship and the topic. So these words should stand out already. So relationship and topic. Those seem to be factors. And so what happened is that participants spoke to either a parent or a friend either about a personal topic or a non-personal topic. So basically we have 4 different types of conversations going on, and we're going to measure how long each conversation takes in minutes. So I want you to do the same thing that you did in the last example, show all 4 conditions, figure out what the factors and levels are, and then state the 3 null hypotheses. And then we'll go on to look at some data to see if we can reject any of those null hypotheses. All right, so if you haven't already tried this problem, please pause here so that you can try on your own, and then we'll go through and answer them together. So let's look at our factors, levels, and 4 different conditions. So we see here that factor A is going to be made up of the friend versus the parent that the person is talking to, and factor B is going to be made up of the non-personal and personal topics that they're talking about. All right, so let's go ahead and label the factors. You should have picked this up from the description. So factor A is going to be relationship type, right? And then the 2 levels are friend or parent, right? So these are the levels that we have decided to use for this factor. And so I want you to realize that this factor A label it's much broader, right? And we could have included all kinds of levels. We could have included sibling or romantic partner or spouse, right? So these kinds of things can change. What's not going to change is the factor label, but we get to pick the levels. All right, so the other factor, factor B, hopefully you have already written this down somewhere, is conversation type. So what is it that they're talking about within the conversation? In this case, the 2 levels that we have chosen are non-personal, so maybe like the news or what's going on at school, right? And then personal, so maybe more like relationships or how the person's feeling, so those kinds of things. So we're going to use these 2 different levels in this factor. So now we're going to fully cross both factors and we're going to come up with 4 different distinct groups. So the first group is the group that's having a non-personal conversation with a friend. So again, maybe something about the news and they're talking about it with a friend. The next group is having a personal conversation with a friend. So maybe about feelings or relationships with a friend. Again, these are not the same groups of people. So this is one group of people talking to their friend, and this is a whole separate group of people talking to their friend. And then we have some people who are having a non-personal conversation with their parent. All right. And then finally, we have one last group of people who's having a personal conversation with their parent. So now we have fully crossed these 2 factors so that we get 4 conditions at the end of the day. So we've now answered the first 2 questions. So now we have to set our null hypotheses and then look at the data and see if we can reject any of them. So again, we're going to have 3 null hypotheses, 2 for main effects, 1 for interaction. So factor A, factor B, interaction. So in this case, our factor A was relationship type. So we'll start with that one. So there's no difference in conversation length between parents and friends. So it doesn't matter who you're talking to, if it's a parent or a friend, the conversation length will be the same. So that's our null hypothesis. And if we get a difference, then we can reject that null. The second null hypothesis is about factor B, which is the topic. So here we're going to say that the null stands for there being no difference in conversation length between personal and non-personal topics. So again, if we find that there is a difference in length in time of how long people are talking to one another between personal and non-personal topics, then we can conclude that there is a main effect and we can reject that null. And then finally, we have our interaction, which of course is combining the 2 factors. And a good thing to keep in mind when you're putting together your null hypothesis and your alternative hypothesis for your interaction is that it should include the word depends, okay, or depending on, because you will formulate a sentence in such a way that it will make sure to include both factors. So the way we would do it here is saying there is no interaction, and I'm going to put it in some more informal language, such that the difference, there should be one such that the difference in conversation length between parent and friend does not depend on the topic. All right, so any differences between conversation length between parent and friend won't change depending on what it is that they're talking about. All right, so you might already be thinking, well, I don't know, I talk to my friends about different things than I talk to my parents about, so I think it would depend on what it is that we're talking about or who I'm talking about it with. So let's take a look at what the data state. Okay, so let's see if we can reject any of these null hypotheses. So once again, I'm going to show you a graph, and then we'll see what we can do with it. So here are the data for how long these conversations on average took place, and this again is in minutes. So if participants are talking to their friend about non-personal things, they talk to them on average for about 16 minutes. If they're talking to a friend about personal topics, they talk to their friend for on average 20 minutes. Now we'll move on to parents. If someone is talking to their parent about non-personal things, that conversation on average lasts about 10 minutes. And if they're talking to their parent about personal things, that conversation on average lasts 6 minutes. So we definitely see some differences going on. We'll go ahead and put those numbers into a table so that we can see if there's anything going on, right? So we can look at the numbers as well. So we're going to use both of these to see main effects and interactions. So first we're going to see, is there a main effect for factor A? So are they speaking longer or shorter to a friend versus a parent? So here we can see that on average people are talking to their friend up here, but only talking to their parents down here. So that seems to be a big difference, and we also see it within our table. So here, participants are talking to their friends for longer amounts of time than they are talking to their parents. So it looks like we have a main effect of a relationship type, so that people are talking to their friends longer than they are talking to their parents. Now, is there a main effect of conversation type? So on average, people are talking about personal things about here. I'm looking at these two gray bars. So if I were to average those out, they'd be about here. And if I were to average the two black bars out, they'd be about here. So I'm doing this in my head, but it looks like right here. Not that big of a difference, right? And then we can also see it here. So non-personal on average is about 13. Here it's about 13. So I'm just looking at these numbers. I'm averaging the 10 and the 16 here and the 20 and the 6 here. So you'll notice that there isn't really a difference between non-personal time and personal time, unless you're looking at which conversation type they're having with whom. All right, so let's use our handy dandy lines to see if there is an interaction. So once again, I'm going to simply put a line from one black bar to the other and then from one gray bar to the other. So this here is the difference in time for non-personal topics between friends and parents. So we can see that it goes down for parents. But when we look at personal topics, we see a much steeper line, right? So people are talking to their friends more about personal and less about they're talking to their friends more about personal and much less to their parents about personal. So we see a very different line here. So now we can see that these two lines cross, okay, which means that we have an interaction. So how long people talk to another person depends on what they're talking about and who they're talking to. Sorry, I lost my train of thought for a second. So I'll say it one more time. So how long a conversation lasts depends on what the topic is and who they're talking to, right? So if you were going to predict who would talk the longest, you would put someone talking to their friend about a personal topic. And if you want a conversation to last a very short amount of time, you would put someone talking to their parent about a personal topic, right? So we see differences in how this affects conversation time depending on who it is that they're talking to. So you keep hearing that word again, depend, right? So again, conversation length between friends and parents depends on what it is that they're talking about. Or you can even say conversation length for non-personal versus personal depends on who it is that they're talking about. All right, so that means that we can reject that interaction null hypothesis. So it looks like we have a main effect of factor A, no main effect of factor B, and an interaction. So isn't that cool that we can do 3 different null hypotheses in one test, you guys? Come on. Hopefully you found this as exciting as I do. I love two-factor ANOVAs. It's a very, very popular design when running studies. Because you can test so many things at once. And that's why I'd like for you to be familiar with them, because you will run across a lot of studies that use this design, and I want to make sure that you understand what it is that they're testing for. And if any of you are moving on to methods courses or anything like that, this is a very good method to understand before you go on and try it on your own. So if you'd like more practice, it's in chapter 13 of your book, and I hope you all are having fun with your ANOVAs, and I will talk to everyone real soon.